Hello, everyone. I'm Emre Yorgancigil, neuroscience PhD and postdoc researcher at Acıbadem University, Istanbul, Turkey. Welcome to my poster presentation as vascular validity of fNIRS method in assessing cerebrovascular reactivity in prefrontal and occipital cortex of the brain. Now I will share my screen and I will show my results and my presentation to you in my poster video presentation right now. At the first slide, I want to talk about fNIRS device. fNIRS is functional near-infrared spectroscopy device, which we used in all experiments in our study, in our neurovascular coupling study. We use infrared light to measure hemodynamic responses, which depend on cerebral activation or deactivation during our experiment. As you see, there is incident light and detected light, and there is absorption of fNIRS device mechanism. It is totally harmless to the body, and its working principle is very similar to pulse oximeter device. And this is the neurovascular coupling mechanism, which I assessed in my experiment with the results of fNIRS neuroimaging method. There have to be first cognitive task or physiologic task or metabolic task at the first. It creates a neuronal activity, increased metabolism of the neuron, and neuron cells blood flow demand is increasing, and for the response, enhanced blood flow in the task-related region, and measuring the oxygenated hemoglobin and deoxygenated hemoglobin levels with fNIRS methods. We can use fNIRS methods to measure oxygenated hemoglobin of the blood or deoxygenated hemoglobin level of the blood of the cerebral arteries, cerebral arterioles, and cerebral capillaries, all kinds of cerebral vascular structures of the brain. And this is the comparison of fNIRS device with EEG and fMRI device. As you see, fNIRS has moderate resolution with compare with EEG and fMRI, but very low cost, low operational cost, and it has very low sensitivity to movement, and it is mobile, and it has very, very high ecological validity of subject's natural environment, which is advantage, which I select fNIRS device for my vascular coupling mechanism study. And in my experiment, I have two kinds of recordings. One recordings from the PFC region of the brain, and other recordings are from the occipital region of the brain. In PFC recordings, we have 8 subjects as 2 female and 6 males, and they are the age intervals. And this is my prefrontal cortex experiment design. My experiment starts with stroke task. This is a very important conflict task, which used every prefrontal cortex study, and then I applied flicker light to subjects, then hyperventilation task, hypoventilation task, and we finish with head down and up maneuvers with physical exercises from the subjects, as you see. So this is my experiment media, and this is subject, and this is a screen of the stroke test, and this is fNIRS device. With fNIRS device, we are recording prefrontal cortex hemodynamic response from there, from this region. And this is our brain cartography of the prefrontal channels of fNIRS device. Our device has totally 15 optodes, as 8 optodes for the source, light source, and 7 optodes for the light detectors. And these 15 optodes compare as the 22 channels, and they are the channel numbers of our cartography, prefrontal cortex cartography of the brain. And so you see they are the block average results of the hemodynamic responses. You know, they are the hemodynamic responses per second. This 40 seconds is our experiment interval, all experiment interval. With the experiment, the hemodynamic response is increasing, and this is the incongruence Stroop task result, and this is the neutral result, and this is the congruence result. They are the results of the channel 1 to channel 9, and they are the results of the channel 12 and channel 20 of all participants. As you see, incongruence hemodynamic response is more better and more higher than other congruence and incongruence neutral results, and they are the expected results of my experience in healthy subjects. In Stroop task, we expect to see increased hemodynamic response to incongruence Stroop stimuli in all participants, and this is the validation of the Stroop test with fNIRS methodology in prefrontal cortex. And this is other methods, other preprocess method, but this is the golden standard preprocess method of the fNIRS methodology. So they are the important results of my experiment. And this is the neurovascular coupling tasks as hypoventilation, hyperventilation, flicker light stimuli, and head up and head down physical exercise. After just after Stroop task finish, subjects started to apply these physical exercises as hypoventilation, and stop breath, and hyperventilation, and light and head moves, head down and head up. And as you see, head moves are the superiority of the hemodynamic responses in all channels, and they are the block average of all 8 participants, by the way, and other channels from channel 12 to channel 20. Every time head moves are more compared with other hypoventilation, hyperventilation, or light stimuli, but hyperventilation is significantly more than hypoventilation, as you see. This is the other method, and they are the result of our occipital recordings. In occipital recordings, we have 9 subjects as 3 female and 6 male, and they are the age intervals of our subjects. For occipital design, we didn't apply Stroop task because Stroop task is a prefrontal cortex specific high cognitive function, high level of its measure firstly, primarily high level activity of prefrontal cortex. So we don't need to check Stroop stimuli in occipital design. In occipital design, we have only physical stimuli as flicker light, hyperventilation, hypoventilation, and head down and up exercise with 3 random order, but at last 3 repeats of the head down and up stimuli. And this is our brain cartography as occipital channels. In occipital configuration, now again, like prefrontal cortex cartography and configuration, we have 15 of dots as 8 for the source and 7 for the detector. So we have 15 of dots for the 22 channels totally, and they are the results. As you see, head moves are superior, but port is superior all the experiments, and notice light stimuli is bigger than bigger hemodynamic response than prefrontal cortex recordings. As you see, light stimuli is bigger, and hyperventilation and hypoventilation has lesser hemodynamic activity compared with others. But as you see, these block average graphics are irregular, and kindly thick because of the low signal quality. fNIRS neuroimaging device is best fit for prefrontal cortex recording. We prefer to use fNIRS device to measure hemodynamic activity in prefrontal cortex region because of the low noise, because of the low hairs, especially in women with a high hair capacity. We have very low signal quality, and so we see very irregular hemodynamic response graphics. We don't like occipital results. Better result. And they are the ANOVA analysis, t-test ANOVA, ANOVA analysis for the multiple compression test between the hemodynamic response graphical levels of all stimuli. As you see, they are the significant results in prefrontal cortex. Head stimuli is significantly higher than occipital cortex. As you see, and there are the significant results in prefrontal cortex hypoventilation. In prefrontal cortex, head stimuli is significantly higher than hypoventilation. In prefrontal cortex, head exercise is significantly higher than light stimuli. And when compared with occipital cortex and prefrontal cortex, head stimuli is significantly higher hemodynamic response in prefrontal cortex than occipital cortex. They are the significant results. We calculate this from the 0 level to maximum amplitude level of the graphics. And with the 2-case multiple compression ANOVA results, they are the all significant results. Prefrontal cortex head is significantly higher than occipital cortex head. Prefrontal cortex head is significantly higher than hypoventilation in prefrontal cortex and light in prefrontal cortex. They are the summarized significant results of our experiment. And we have another validity round of the prefrontal cortex experiment also. This time we have just 6 subjects, as 2 female and 4 males. And we focus on we remove light stimuli because prefrontal cortex is not specific to light stimuli, just hyperventilation. Deep breath and stop. Deep breath, stop, and head down, and stay down. Stay down for the 20 seconds. This is our validation turn. And these are the results, as you see. Head stimuli every time has the more level compared with others. Every time has the more level. Head stimuli is very dominant in the hemodynamic response, but compared just with hypoventilation and stop breath, we see hypoventilation is higher hemodynamic response than stop breath. As you see in stopping breath, oxygen level in the blood is lowering, is reducing, and for the response, it's again increasing. These are the results. And these are the oxygenated hemoglobin results. It's very similar with oxygenated hemoglobin results. They are the oxygenated hemoglobin, HbO, and it is the deoxygenated hemoglobin results, HbR. Okay, and they are, they are the blood vessels in our brain. Or fNIRS device mainly focus of the capillary of the anterior cerebellar artery, as you see. Our skin conductance and our depth level is about between 2 centimeters. So we can measure oxygenated hemoglobin level of this capillary, mid capillary of the anterior cerebral artery. Okay, thank you very much for seeing my presentation. I'm ready to answer your question all my session. Thank you very much and have a good webinar. for the next sessions. Goodbye.